Okay, so I am making this video and just gonna run through the entire test with some explanations along the way. Test scores were not the greatest, and I feel bad about that. And so, I wouldn't normally do this type of video, but this is my somewhat of a gift to kind of analyze these problems a little more meticulously than we traditionally do. A landscaper pumps water into a pond, and the depth of the pond increases at a rate modeled by yada yada, where t is the time and minutes since the landscaper started pumping water into the pond, and r of t is measured in inches per minute. How much did the depth of the pond increase from 0 to 10? So this is a rate, and if we integrate this rate, we will find the change. So this is the rate at which the depth is changing. So if we integrate this rate, we'll find the amount of change. So we just need to open up our calculator and do Shift plus and integrate this function from 0 to 10. 0.15 times x plus 0.1 times x times sine of x squared divided by 8, close parenthesis, close parenthesis. I did x instead of t, whatever. Control enter for a decimal, and we have arrived at option D, 7.501. That's that. But keep this massive idea in mind. If you have a rate and you integrate that rate, this will find the change along that interval, the amount of change. It's a massive idea for the integral. A particle moves along the x-axis so that its position at time t, given by x of t, where t is measured in seconds. The table below gives values of the function x for selected values of t, which is the position. The velocity of the same particle at time t is given by blah. What is the position of the particle at time t equals 12? Well, this massive idea is that if we integrate this velocity, which is a rate, it'll find how much the position changed. But knowing how much the position changed isn't enough. We need to know where it started. If we know that the position is 2 at t equals 1, we need to take this 2 and add the change, the displacement being the particle word that we like to use, but we just need to find out how far did it move. And by integrating the rate from what position are we trying to find? At t equals 12, by taking the position at 1 and adding what happens from 1 to 12, I'll do t this time. Oops, I need an exponent. By taking that starting position and adding up the change, I'll find the new resulting position, which is 62.583. And you might be thinking, well, what about the rest of the table? Well, these numbers are legit. Had I done negative 6.75 at t equals 4, what needs to be modified is, well, the integral, right? If you used this as the quote starting position, well, this is the position at 4. So add the change, right? How much did we change? But not from 1 to 12 anymore, from 4 to 12. If I hit Control Enter, I still get the same decimal. And the same would have been true for negative 2. It actually didn't matter which one you chose. Now, if you just look at the integral, right? If you did 1 to 12, if you just look at the integral, you can see that's, oh, it's not one of the options. I thought I made it one of the options, but whatever. That's not the new position. That's how much the particle moved. It's a big difference. It's a big difference. Okay. I remember this next question being the hardest, so forgive me if I have to think about it a little more thoroughly here. If if 0 is less than k, which is less than pi over 2, and the area between the curve y equals cosine of x and the x-axis from k to pi over 2 is 0.1, then what does k equal? So the area underneath cosine is 0.1 from k to pi over 2. So if we, I think I need to do a little bit of work on the page here. This is not pure calculator. What we're saying here is that the integral from k to pi over 2 of cosine of x equals 0.1. That's what we're saying, because the area underneath the curve, well, cosine minus the x-axis, which is just a horizontal line at 0. So we're literally, this is the cosine curve, right? Looks like that, and we just need to find the integral from k to pi. Maybe this is k, right? And pi over 2 is where it hits 0. So we just want to find that area, which is the integral. Well, what is the integral of cosine? What does this mean? That the integral of cosine is sine, and we're going along the bounds k to pi over 2, and that equals 0.1. So sine of pi over 2 minus sine of k equals 0.1. You with me? I hope I didn't lose you. I integrated and then plugged in the upper bound minus plug in the lower bound, which then means, and what is sine of pi over 2? That's of course just 1. So we want to know, I'm going to add sine to the other side and subtract 0.1. So 1 minus 0.1 is 0.9. So when does sine of k equal 0.9? K is just our new variable, right? So I'm going to go to a graph and just ask myself, when does sine of k, but I'm typing x, when does it equal 0.9? I need some proper, I don't want to choose the wrong answer, so I want to go from essentially 0. You can type pi over 2, by the way, and it understands. So where's that intersection? Menu, analyze, intersection. 1.119, which would round to the option D, 1.120. Bit of a more conceptual one here. We really gotta, it involved being able to integrate, but then suddenly we needed to solve. Go ahead and rewind and watch that back. I think I put my thoughts together there quite well. I think. The base of a solid is the region in the first quadrant bounded by the y-axis, the graph of y equals inverse tangent of x, the horizontal line y equals 3, and the vertical line x equals 1. For this solid, each cross-section perpendicular to the x-axis is a square. What is the volume of the solid? Now, inverse, like, if you need to plot everything on your graphing calculator to envision what's happening, that is going to take you extra time. Ideally, you wouldn't have to do that. I suppose I'll do it just to help me explain. But for the most part, I read that and I just sort of, I don't know, I can just see the graph. You do learn what the graph of inverse tangent looks like in a algebra 2/pre-calc, but if you don't remember, I mean, there it is, right? And so there's y equals 3, there's inverse tangent. I don't need to literally plot a vertical line at 1. That's like unnecessary. We just need to know that it's the y-axis and x equals 1. I could adjust the window if that like helps you imagine those boundaries, right? So now this is it. From 0 to 1, we want to, this region right here between the blue and red line is our region. And suddenly there are squares sprouting out of this. So the distance between blue and red is the length of the side. It's the length of the side, yes? So there's that, and this is our S. So we just need to integrate from 0 to 1. Why 0 to 1? Because that's the bounds of our region. And this is the important part. We're doing 3 minus inverse tangent, because by doing so, by subtracting the top minus the bottom, we're finding that distance s. We of course need to square that, and we're good to go, right? This is the area of the square, and we just need to integrate it along the bounds 0 to 1. So I will open up a calculator, and I will shift plus 0 to 1, 3 minus inverse tangent of x dx. Oh, I forgot the squared. Squared? I don't think I'm putting that in the right spot. So I think it looked like it was only squaring the... There we go. That looks like it's squaring the entire thing now. That's actually, I'm looking, is that kind of small for you? Control plus. I don't know. I hope it's legible. And hit enter, and we get the decimal 6.612, which is option B. I'm gonna try something for 30 seconds mid video here. Maybe document, view. Not seeing like a zoom in. I'm sorry. I hope it's good enough. Pinch in on the video. If you're on mobile, you can pinch into videos. What is the volume of the solid generated with the region bounded by the graph of that and the lines x equals 0 and y equals 5 is revolved about the y-axis? So, x equals 0 being the y-axis. We could graph this one as well. You know, you're not really meant to be, I'm just being honest. You're not really meant to take such time to plot it on your calculator. It's just not the intention of the problem. You're just meant to plug it in the integral. You're not meant to dilly-dally with you're just not meant to do this. Now, did you know I just sort of casually did that? This is not a function. So it's actually a relation. It's actually a relation. So I'm typing this in because when I plot this, this is, well, I shouldn't say it's not a function. I guess this one is a function, but like the fact that it's in terms of y is making it like not fit the mold of our calculator, so I had to change to a relation. So here's the graph. Now I can zoom in there. Zoom in. Bippity. There we go. That's pretty good. And so here's the line x equals 0, and then the line y equals 5 at the top. I think I can still type y equals 5, even though, yeah. So we're taking this region, and we're revolving it around. So it's just kind of making this sort of a cone type situation. Can you envision sort of like a half of a pill, maybe? Like if you took a pill and cut it in half, maybe. But the idea is that, oh, it's in terms of y, and we just need to do right minus left. Now, like I said, it's just like there's no washer situation here. It's not a washer. There's no hole in the middle because everything's flush, and the x equals 0. And now this visual makes it obvious that it's flush, but the description, there wasn't some other function that we were cutting out of the middle, right? It was just the one function and the x-axis. Sorry, excuse me, the y-axis. So for that reason, I feel like visualizing this isn't too bad, but let's get to the point. What are we doing now? Right minus left, left being this vertical line, right? And everything's in terms of y, right? We're saying this is the right function, and we're subtracting the left function, and we're squaring it. And we're saying pi r squared. Now, what are the bounds? Well, because we're rotating around the y-axis, our bounds are in terms of y, and that's the bottom of the graph being at, excuse me, not 0. I suppose the graph is helping me with that. It's at 2, right? Because of the minus 2 here. So I a little too quickly said 2 there. That's my bad. We're going from 2 to 5, not 0 to 5. Okay? And again, that's just because of the minus 2. All right, so now if we plug that in, you probably don't need to see it plugged in at this point. You probably just trust the decimal that's on the page, but we'll plug in something to our calculator one final time. I don't really need to do the minus 0, right? So I'm just going to do square root of y minus 2, and then squared, which is really just getting rid of the radical. I forgot the pi at the beginning. Let me go back and add that in. Pi times that. 14.137. All right. Feel free, go back and rewind. But yeah, there's that. A little bit more calculator, of course, here with the calculator active. Only 16 minutes with a bit of a 90-second introduction. I think we're on a good pace. The function f and g are given as blah. So this is, of course, the line 2x plus 4, and this is, of course, the parabola 2x squared. Find the area of the region. So it's just, you know, if all you do is this, you're finding this entire area, but you want to subtract away this stuff, right? Which is why we're doing top minus bottom. So by doing top minus bottom, you find the area in between the curves. Now we need to know where this intersection is. It is graphing calculator active, so I could plot them and find the intersection. It's also, the algebra here is actually not that bad at all. As I was grading, I saw several, more than several people do it by hand, which is great because it's probably quicker than what I'm doing here. Intersection, we get a -1. Intersection, we get a 2. I'm, of course, looking at the x values, not at the y values. The y values at this present moment don't mean anything, and I don't think they'll mean anything for the entire problem, if I recall correctly. We're just going from left to right. So -1 to 2. This entire integral isn't even that bad by hand. It's really not. But we will plug it into the calculator. And we'll do 2x plus 4 minus the parabola below, x squared. And it came out to a, oh, I need the variable at the end, of course. Comes out to a clean 9. Was 9 the answer? Was 9 the answer? Did I typo? Yeah, 9 was the answer. Okay. To me, that felt off, and I didn't want to try to stare at the screen. So, the base of a solid is the region bounded by these two functions. Find the volume of the solid with the cross sections perpendicular to the x-axis, which are rectangles with a height of 4. So, instead of doing an s squared like we did for number 4 here, it's now, what's the area of this rectangle? The area of the rectangle is simply 4 times s. So s is this, right? Top minus bottom. When I say s, I mean the side of the figure, right? I'm using the variable that we used in class. I hope that's okay, right? By subtracting the two functions, you are finding that vertical distance. So that's one side of the figure, right? And suddenly a rectangle is sprouting out of this figure, and it's 4 units tall. So the integral is simply 4 times this. Well, that's literally the same integral times 4 out in front. I'm not even going to plug that into a calculator. It's simply 36. Okay. Now, this same base of a solid, Find the volume where the cross sections are still perpendicular to the x-axis when they are right isosceles triangles. So the area of a right isosceles triangle with the leg lying on the base is simply half s squared. Now, if you are not recalling that formula, remember a square is s by s, so the area of the square is s squared. And suddenly when we make a right isosceles triangle, we're cutting the square in half. And so the right isosceles triangle was half s squared, because this is one of the legs. It was a different story, though, when we made the hypotenuse, right? It was a different story, okay? This, I suppose I do need to plug into the calculator. So it's essentially the same integral with a squared, and then I just need to divide it by 2 to get half that. Oops, what did I just do? 81/5 is the answer. I just accidentally hit divided by 2 again. 16.2. 16.2. A lot of people got this FRQ right. A lot of right answers here. This was probably the best part of the exam, was this FRQ. It was a pleasure to grade. A solid is generated. This is the worst part of the FRQ, of course. A solid is generated when the region bounded by these two functions revolves around the line y equals 8. Find the volume of this figure. Show the integral you evaluated in your calculator. So here, because this region, what I was pointing out in class is that it's not flush with the line that we're revolving around. The line that we're revolving around is way up here. And remember, we learned that this actually was the intersection -2, 8, or excuse me, 2, 8, not -2. And so when we revolve around this, right, the parabola is creating the outer edge of the figure as it revolves around. And then, like, I'm literally turning my iPad, and so here, let me clean slate here. What's happening is we're revolving around this line, and so it's something like this, something like this, all right? And so we're revolving around, yeah? And so, but this is also, this is being cut out of the middle, all right? So we're like cutting this cone shape out, and we're left with, you know, whatever this is. Can you see what, can you see that? I mean, I wish we could draw with 3D perspective more easily, but you just need to realize that this stuff is being cut out. This is empty space. And this is where the three-dimensional object is that I'm scribbling in black. That's the three-dimensional object, okay? So the outer radius, or the outer figure, the outer edge, the outer discs has a radius of 8 minus 2x squared. That's the outer, right? 8 minus the function that's furthest away, which is the parabola. Then 8 minus the function that's closest is the inner. Now look at what I did there, right? 8 minus the function. I put it in parentheses. And so this is like that big radius. This is that little radius. And so we're doing pi r squared. This part of the integral, as if we didn't cut anything out, this is us cutting out the inside. This is a nice uniform solid, and the minus part is us subtracting away that inside cone area, creating that funnel. All right, and when we plug it into the calculator, thank goodness this is the last time we have to touch the calculator. Just a little tedious, I'm sure you know, right? It's a little tedious. Forgot the pi out in front. Pi times, so parenthesis 8 minus 2x squared minus parenthesis 8 minus parenthesis 2x plus 4, close parenthesis squared, dx. Control Enter. I guess I could have been doing that the whole time. Sorry. Control Enter. 271.434. And there's that. And I'm closing this. All right. So, yeah. I think everything in the calculator section besides number 3 is a pretty straightforward question. Not the particular, there weren't any tricks, right? I'm not arguing that these were easy. I'm just saying they're straightforward. Nothing about calculus is easy. And then, again, I would say these are straightforward, but not necessarily easy. All right. If the average value of the function f on the interval 3 to 8 is 6, what is this value? This setup is stolen straight from a progress check question. So I was hoping that was, in your favor because you did the progress check. So what are they saying when the average value of f on 3 to 8 is 6? They're telling us that that is equal to 6. That's the average value formula setup. The average value of f is this integral here. So what do we, now you might be thinking like, okay, what good is that? Well, it's worth a lot because we're interested in the value of this integral over here. Now, can we solve part of this? Well, I think breaking it up into chunks would be beneficial. Okay. This integral is easy. It's just 8 minus 3, which is 5, times 1, which is 5, right? This is just a horizontal line. I'm thinking of this graphically. I'm not even thinking about doing that by hand. I'm thinking of it graphically. It's a horizontal line at 1, and I just want to know the area underneath it from 3 to 8. So that's a base of 5 and a height of 1. 1 times 5, it's 5, right? Because at its core, an integral is sort of like the change, the area underneath the curve, right? Like sometimes there's negative area, sometimes there's positive area, but area. So that's 5 plus, and then this is, oops, I forgot the 4, sorry. Well, 4 times this integral. Well, this information is so valuable because this is a 1/5, of course. And well, if you just multiply by 5 to get rid of the fraction, we're learning that the integral is equal to 30. Right? This integral had to be 30 in order for this to be true. 1/5 times 30 is 6. So we're learning the integral is equal to 30. So this integral here is 30 times the 4, which is 120, plus the 5, which is 125. Okay. All right. Selected values. I mean, what the key to unlocking all of this is this. Right? I mean, this over here, if you already knew this was 30, this I would think this question, I would think it was easy. I think. Maybe I'm mistaken, right? If you're still not comfortable, just realize that, there are two main properties of integrals. If you're adding or subtracting things within an integral, you can break it up, right? We've done that a lot though, right? You can break it up. And if you're multiplying by something, some constant is multiplying, you can always factor it out. And I'm sure there are other properties of integrals, but But those are the big ones we use all the time. And so I factored out the 4, and if here you're like, well, 5 was the hard part. You're like, yo, Mr. Skis, like you're kind of just glossing over the part that I got stuck on. Well, I mean, you don't have to think about it as area. What's the integral of 1? X, of course. And then plug in 8 and plug in 3, and 8 minus 3 is 5, right? Just do the, this is capital F, and you did F of B minus capital F of, right? You're just doing the fundamental theorem. You've done this a lot. You can't tell me you haven't. And you get 5. All right. Probably should not dwell on a problem for that long. Selected values. This problem had a typo. I tossed it out, but I fixed the typo for the sake of this demonstration. Selected values of the twice differentiable function m, its derivative m prime, and its second derivative m double prime are given in the table below. M of t models the mAh of the charge of a battery, models the milliamp hours of the charge a battery has, where t is the time in minutes since the battery began charging. Which of the following is equivalent to the average rate of change in milliamp hours per minute on the interval 0 to 25? So this is, m is not a rate. M models, like, it's the charge, right? It's just like, and that is like position, all right? So it's, how much battery is there, not the change in battery, okay? And it says, which of the following is equivalent to the average rate of charge in milliamp hours? So average rate at which we're charging. Average rate of, I think this is, oh, should that have been an, that's not the typo. That should be an N. Average rate of change. Average rate of charge. I mean, could it be charge? Average rate of charge? Average rate of charge, average rate of change. The point is the units are the giveaway. Let's not it's we're going to milliamp hours per minute. I think that should have been an N. Okay, I'm getting. All right. The point here is that this question is meant to kind of trick you into thinking that it's got to be one of these, right? Because it's got this word average, right? But this would give you m prime of 25 minus m prime of 0 all over 25, which m prime is already milliamp hours per minute. And as you divide by 25, you get milliamp hours per minute per minute. So this is like the average change in the change, right? It's the acceleration of the battery. I'm using bad math language there, but it's like the acceleration of the battery. Don't ever say that anywhere, please. I'm making an analogy for the sake of your brain, because it's 2 layers deep, right? This is finding the average value of m double prime, and this is finding the average value of m, and this is finding the average rate of change of m. Right? This is taking the values of m and dividing them by 25. That's just average rate of change, right? M of 25 minus m of 0 all over 25 minus 0. You know what this is equal to? The integral of 1 over 25 minus 0 times the integral from 0 to 25 of m prime. You realize these two things are equal to each other? Because when you integrate m prime, you get m. So when it asks for the average rate of change, or even average rate of charge, this is the only option. This is where the typo was. This was a 2500, by the way. I tossed this question out. But this is the only option that even has the correct units of milliamp hours per minute. These are milliamp hours dividing by 25 minutes that elapsed, milliamp hours per minute. This question could have said, what is the average value of the rate of change of the battery. We're finding the average value of the rate of change. But that's just kind of wordy. What we're going to stay instead is, what is the average rate of change? We don't need this extra value of the rate. We can just glue the thoughts together and just say average rate of change. Average rate of change has and will always be f of b minus f of a all over b minus a. But now with this new integral lens, we're realizing, wait, average rate of change is the same thing as the average value of the rate. Really let that sink in. Pause. Stare at this. It's kind of a big deal for unlocking these connective tissues here that are integrals and derivatives. All right. I really need to spit it up. I'm having too much fun. The function f gives the rate of evaporation of water in liters per hour from a pond, where t is measured in hours since 12 noon. Which of the following gives the meaning of 4 to 10, the integral from 4 to 10 of f of t dt in the context described? So the rate of evaporation, so f is the rate of evaporation since noon. So this would be 4 p.m. and this would be 10 p.m., right? Since noon, 4 hours after noon. Okay. So, okay, that makes sense while I'm seeing 4. Okay, okay. This is not 10 hours total, though. That's only 6 hours. So I already know A is wrong because it said the first 10 hours. It's just not right. The total volume of water in liters that evaporated from the pond between 4 and 10. Yes, right? I mean, you're like, it is of course the right answer here. It's in bold, but like, yeah, this is what happened. It's not the amount of water that remains in the pond. That's different. It's just how much, going back to this thought way back in the multiple choice, right? When we integrated, well, I don't have any written work, of course, but when I integrated the velocity, it found the change in position. I still had to keep in mind where we started, but the integral of a rate found the change over that interval. The integral of this rate found the change. We're just figuring out how much changed. We're figuring out, okay, from 4 to 10, this is what happened. Boom. All right. Which of the following expressions is equivalent to the area of the region bounded by the curve y equals natural log x squared, the line x equals cube root of e cubed, or square root of e cubed, and the x-axis as seen in the graph below? So here is natural log x squared. Here is the square root of e cubed. That's just a number, by the way, square root of e cubed. What is the area of the region bounded there? Okay, well, we just need to take the integral from x1 to, right? I don't actually know where this region is starting. Don't actually know where the region's starting. Okay, so where is the region starting? Well, whenever natural log of x squared equals 0, which natural log of 1 is 0. So x squared needs to equal 1, and that means x equals 1. So that region starts at 1. And then I look at my options and I go, wait, is B right? Did I mess up? Should I? No. This is, it said, which of the following expressions is equivalent? This is equivalent, but just not one of the options. Sad face. Sad face. You know, it's not, oh, I didn't mess up and it's not 0, right? This is clearly not 0. The region did not start at 0. This is just, that was wrong. And that this is incorrectly thinking we need to subtract. There's no space underneath, right? It's just one flush region. So it's got to be one of these in terms of y options. Spoiler alert, it's D there. But if it's in terms of y, we need to change our perspective here and go, okay, so I'm rotating. You can't see me rotating, but I'm now thinking this is the beginning of my region, and this is the end of my region, right? I don't know if it's right. And so this is at 3, right? I'm going from 0 to 3. Okay, that's not really a question. And I want to do right minus left. Well, x equals square root of e cubed, right, is my function. That's it. This is my right function. Boop. Now, what's with the e to the y over 2? Well, I mean, again, like this question, like you shouldn't really be. I'm just thinking, like in the grand scheme of them, like who cares why it's e to the y over 2? Who freaking cares? It's right minus left. This is not the right function. So just circle D and move on, right? But if you're inquisitive and you're thinking, okay, why is it e to the y over 2? Well, this 2 got brought down as a power and got divided by 2. So we have natural log x squared equals y over 2. Then we raised it to the power. Oops, the 2's gone. Excuse me. Then we exponentiated each side. So we have x equals e to the y over 2. Ta-da. But that if this were FRQ, you need to have that skill. But it's just not. It's not, right? This is just because you're not watching this just to know how to do the problems. You're watching this to learn, right? At least I hope you are. When you look at these options, I look at the ones in terms of x, and I go, this region does not start at 0, wrong. Then here, I'm just thinking like, what am I subtracting? There's nothing below this curve. It's just function minus 0. So that it's just like, what is this subtraction? It's top minus bottom. This is just the right bound. That doesn't make any sense either. And then here, I understand it's just like, okay, now it's in terms of y. It's a little bit harder, but that was the point of the question, right? I think this is like one of maybe 2 times where we're in terms of y. Okay, so that's just the point of the question. We're in terms of y, and we got to do right minus left. This vertical curve is on the right curve. And so D, right? The second because these are the same option, just flip-flopped. This would give you the same answer except negative, right? That's incorrect. Area is not negative. Okay, moving on. What is the total area of the regions? Total area of the regions between the curves y equals 6x squared minus 18x, y equals negative 6x from 1 to 3. Of the non-calculator multiple choice, I swear this has got to be the hardest problem. It's the most time-consuming. How about that? This question is the most time-consuming. So I do think it does say there is a clue in the question. What is the total area of the regions? Plural. There are multiple regions. Now, where do those regions stop and start, right? We're saying from 1 to 3, but the region is being broken up into chunks, right? It's not one big region. It's actually 2 separate ones because this is a parabola with like a line running through it. And so from 1 to 3, right? I mean, I can draw a sketch to bring this to life. But first off, I want to know when/where do our functions intersect? Let's find out. Oops, those are like terms. What am I doing? Add the 6x over and you get 24x. Factor out the 6x, and you're left with x plus 4. So 0. Did I mess something up? Oh my gosh, I made a blatant error there. Let's try this again, folks. 6x squared. As I add the 6x, this would be negative 12x. Silly goose. Factor out the 6. I'll have x minus 2. So 0 and 2. They intersect at 0 and 2. So, but 0 is outside of the bounds, so we don't really care about that. But here's my line. The negative slope going like this. Okay. And then here's my parabola intersecting at 0 and at 2. So it's doing something like this. And so we want the area of the regions between the curve 6x squared and the line negative 6x from x equals 1 to x equals 3. So there's one region where the line is on top of the curve. And then when they intersect and cross each other, suddenly the parabola, the curve, is now on top of the parabola, or sorry, the line, right? So there's really two separate integrals that we're doing here. Because if you try to do them at once, the crisscross nature, right, it has to be top minus bottom because you need all this area to come out positive. All right, so this is where it's not fun. And I'm already running out of room, right? Which is why I said, hey, the backside's completely blank. So if I focus in on that first integral from 1 to 2, you ready? Lock in here. Negative 6x. Let me just distribute the negative first. How about that? So that's going to be a negative 6x squared, and then negative 6x minus negative, that's plus 8, so that's plus 12x. Okay, so we integrate. So that's negative 6x cubed. When we go up a power, so that's negative 2x cubed plus 6x squared, right? Increase by 1, divide by 2, we get 6. Increase by 1, divide by 3, that's where the negative 2 comes from, and we plug 1 to 2 in. So then when we plug in 2, we get negative 2 times 2 cubed plus 6 times 2 squared minus, plug in 1, negative 2 times 1 cubed plus 6 times 1 squared. 2 cubed is 8 times negative 2 is negative 16. 2 squared is 4 times the 6 is 24 minus 1 cubed is 1 times the negative 2 is negative 2. 1 squared is 1 times the 6 is 6. 24 minus 16 is 8. 8 minus negative 2 plus 6 is 4. 8 minus 4 is 4. Okay, there's that one. So that's this region, I think, as long as I didn't screw anything up. Then we go again from 2 to 3. Let me minus negative 6 as plus 6. So that's 6x squared minus 12x. So this integral is going to feel pretty similar, but not quite the same. So when we integrate, that's going to be 2x cubed. We increased up to 3, but then divided by 3. So that gave us the 2. We're going to increase up to 2, but then divide by 2. So that's going to give us the 6x squared from 2 to 3. So we got to do this again. 2 times 3 cubed minus 6 times 3 squared minus, plug in the 2. 2 times 2 cubed minus 6 times 2 squared. 3 cubed is 27 times 2 is 54 minus 3 squared is 9 times 6 is 54. That's fun. Minus 2 cubed is 8 times 2 is 16 minus 2 cubed is 8. 2 squared, that's a squared, excuse me. 2 squared, which is 4, times 6, which is 24. 16 minus, so this is a 0, minus 16 minus 24 is negative 8, minus negative 8 is a positive 8. So this integral came out to 8. So that's this integral here. And so that first region plus the second region gave me 12. All right. We move on. That is the most arithmetic. I mean, is there any way around that? Right? Like, if you're going to get tested on a question about multiple regions, is there any way around that? You do kind of have to do two separate integrals. All right. Identify the definite integrals that represent the area of the I mean, here's the way around it, right? Number 11, all right? Identify the definite integrals, or integrals, plural, that represents the area of the regions bounded by the graphs of y equals x and y equals 5x minus x cubed. Again, it is finding the area of a region is top minus bottom. Integral of top function minus bottom function. Integral of top function minus bottom. Integral, where did they intersect? That's your left and right. That's your bounds. Top minus bottom. Or if we're in terms of y, where do they intersect? Your bounds are the y values instead, and you do right minus left. That's that. So this is, it is, again, it kind of gave away the answer, right? There's only one integral, or only one response with two integrals. That's because this is two separate regions. There was this cubic curve that was intersecting the line x, and when you solve, you get x cubed minus 4x. So they intersect at 0, -2, and 2. Right? So you've got this cubic curve. You got this line y equals x. And so it went zoop, zoop, zoop. And so they intersected these 3 different times. And so we had to do, the 2 subtracted and the 2 subtracted and found these 2 separate integrals. It's kind of just the way the cookie crumbles. What can we say? All right. All right. The base of multiple solids is the region in the first quadrant bounded by y equals cosine of x and the x and y axis from 0 to pi over 2. Vs is the volume of the solid where it is squares. Vc is the volume of the solid where the cross-section perpendicular to the x-axis is a semicircle, and VE is the volume of the solid where the cross-section perpendicular to the x-axis is an equilateral triangle. Which inequality is true? So they all have the same S, right? Because they all have the same region. And so this is a pretty solid question where it's just like, okay, which one has the biggest volume? Right? Which one has the biggest volume? And so the square is coming out the biggest. All right? So it's got to be C or D. So then the question is, which one's bigger, the equilateral triangle or the circle? And, well, you have something that is roughly 3 being, or this is the 8th, excuse me. Roughly 3 being divided by 8, right? So this is roughly 3/8, I want to say, right? Maybe. And then this is roughly, I don't know. I guess that's kind of tough. How could I put that into words? It's the radical that's weird, right? It's the radical that's weird. How could I, which one's bigger? How do I put that into words? I mean, I guess dividing by 8 just seems like it's going to make it smaller, right? I guess that's my gut take. Does that make you happy enough? Dividing by 8 makes it smaller than dividing by 4? I mean, that's not a perfect explanation. That's my gut reaction. I'm trying to, how can we compare those? I guess we need a common denominator, right? So which is bigger, pi or 2 root 3? This is 3.14. I guess it's the root 3 that's a little tough. How do we put, because I don't know what root 3 is, the decimal. I know it's somewhere between 2 and 3, right? Or, sorry, between 1 and 2, right? Because the square root of 1 is 1. If the square root of 1 is 1 and the square root of 4 is 2, 3 is closer to 4 than it is 1, right? So, I mean, it's got to be closer to 2 than it is 1. So I guess that leads me to believe that this number is like, I don't know, like 1.6 or something, which 2 times 1.6 is 3.2, which is bigger than 3.14159. I don't know. It was the divided by 8 that gave, when I did this problem for the first time, that like I was just like, it's smaller. I don't know, probably rambling. Maybe you don't care. I was just trying to provide a good explanation there. Yeah. I hope, is that satisfying enough? Leave a comment if it's not. Let R be the triangular region, time-wise, 56 minutes. So there's still 30 minutes left on the test. We're almost done with the multiple choice. I'm just thinking like actual test taking, right? And I'm yapping. Let R be the triangular region in the first quadrant with vertices at points. So there's a triangular region. 0, 0, A, 0, and B, 0, where A and B are positive constants. Which of the following gives the volume of the solid generated when region R is revolved around the x-axis? So there's basically a line connecting these two things. And so this region is being revolved around. So really, we just need to know, like, please tell me, what is this equation? What is this equation? Well, it has a y-intercept of b. And it's just a line, right? And it has a slope of what? Down b over a. So a y-intercept of b and the slope of down b over a, so negative b over a. This is the line negative b over ax plus b, right? Y equals mx plus, that's kind of cute. The y-intercept is b. Y equals mx plus b. How adorable, right? So it's in slope-intercept form. So now we just need to do top minus bottom, except, the bottom is the x-axis. This is minus 0, so minus nothing. And then squared as we revolve it around. What are the bounds? From left to right, 0 to a. So this is a b, wrong. This is a b, we don't want that. 0 to a, this doesn't have the negative slope, so a it is. I like that question, not too bad. I think the toughest part is just coming up with the line, but I don't know, slope-intercept form, not too crazy. But that's what's tough about calculus here. We're almost an hour into the video. If you're still here, appreciate you. What's tough is it's like, you're probably looking at this going like, you might have got this question wrong. You might have thought it was tough in the moment. And then you're just like, I just kind of had to come up with the line. And you're probably thinking, yeah, I know the equation of a line, right? Like, that's what you have to have belief in yourself. You have to believe that you are capable of the problems. Not hardly anything about this problem was calculus. Or I don't know, right? Like, because like the setup of the answers is sort of already giving away, right? It didn't even like tease you with like a minus something else, right? Like it's just sort of line squared. But can you write the, like, I don't know. I'm getting distracted, but you gotta believe in yourself. You can come up with the equation of this line. I know you can. I know you can. I know you can. There's not a single calculus student I've ever interacted with ever that I thought to myself, they couldn't even tell me the equation of a line. I from the worst performing student to the best performing student, I know everyone's capable of telling me the equation of a line. You just got to draw the sketch and go, oh, it's a line. Find the line. I don't know. I feel like this is a question that a lot of you probably thought was tough in the moment because it was all just. Anyway, it's 60 minutes here. Let's keep going. The area of the region bounded by the graphs of blah and blah. They're in terms of y. It's the last one where it's in terms of y. So we just need to figure out where they intersect. And again, the semantics of area of the region. Singular. So there's not multiple regions here. We don't need to be in a panic. We don't need to be in a panic about, oh, is this a long problem where I need to break it? Nope, it's a region. Singular. Okay, so where do these regions intersect? Well, set it to 0, add that y squared over, and subtract that 4 over. Factor it up. And we learn the region, or yeah, the region is bounded by 2 and -3. Okay, so that's our bounds, -3 to 2. And we just need to do right minus left. Now, which one's on the right? This is a situation where, well, if I get it wrong, if I do right minus left, or excuse me, if I do accidentally do left minus right, what's the worst that can happen? The answer is the opposite of what it should be. So if I get -125 over 6, oh, it's got to be B. I just had them backwards, right? Right? So let's flip a coin. Let's flip a coin. Do I do 4 minus y squared or y minus 2? I'm going to flip a coin. Flip a coin for me. Heads is the first one. Okay, I got heads. I'm doing the first one. Doesn't matter. 4 minus y squared minus y minus 2. Okay. So -3 to 2. Let's combine our like terms here. So we're going to have -y squared minus the y minus -2 means +2. Added with the 4 is a 6. Positive 6. Then we're going to integrate, and we'll have -y cubed over 3 minus y squared over 2 plus 6y along the bounds of -3 to 2. Then we're going to plug in 2. So -2 cubed over 3 minus 2 squared over 2 plus 6 times 2 minus, now we're going to plug in -3. Negative, okay, this is right. This negative is this negative, and then this is the number -3, and it's getting cubed. Then we're minusing again because of the function, but then this negative is because the bound is negative, and then it said plus, so I'm doing plus, and then 6 times the number is -3. All right, and then we just carefully do some arithmetic. So this is going to be 2 cubed is 8, so that's -8/3. Minus 2 squared is 4, divided by 2 is 2. 6 times 2 is 12. Minus, okay, this is a 3. It doesn't look like a 3. My bad. -3 cubed is -27. Divided by the 3 is a -9, but there's a negative out in front, making it a +9. -3 squared is 9. Divided by 2 is 9/2, but it's minus, so -9/2. And 6 times -3 is -18. Okay? So this is -8/3 plus 10 minus 9 minus 18 is -9, and then minus the 9/2. This is -8/3. The 10 minus the negative, that's +9, so that's +19 minus the 9/2. Multiply by 2 over 2 and 3 over 3, and we get -16/6. I need a times 6 over 6 here. 9 times 6 is 54. So plus 104 over 6. Ooh, minus the negative 9 is plus 9 halves. So plus 9 times 3 is 27 sixths. 27 minus 16 is 11 sixths. 104 plus 11 is 115 sixths. Oh no, where did I mess up? Did I mess up the 104? 6 times 5. Oh, 6 times 1 plus the 5. That's 114. 114 plus 11 is 125. In that situation, if I did all that work and I look at the answer choices and I don't see anything, I'm choosing B anyway. I'm like, big number divided by 6. I probably just messed up somewhere. B, move on. For real. All right, last one. Let S be the region enclosed by the graphs of y equals 2x and y equals 2x squared from 0 to 1. What is the volume of the solid generated when S is revolved about the line y equals 3? So this is exactly like the FRQ, just we need to choose the right integral. So it's a lot easier because you don't have to write anything yourself. You just got to look at it and find it. So I like all the pi's. What am I seeing here? I'm like, okay, this one's in terms of y, but I'm rotating about a horizontal line. If you're rotating about a horizontal line, you need to be in terms of x. So this is just out. And then, okay, I'm looking here and I'm like, well, this is clearly implying there's a hole, where this one seems to be convinced that there's not really a hole because there's not. And also, this is missing the squared. I probably should have put a squared to make that more appealing, right? Because, like, we're not really doing pi r squared. You know what? I think I'm just going to cancel that out for that reason, right? Yeah, that one doesn't seem logical. Okay, so I guess which way, right? Which, because these are just flip-flopped, right? 2x squared and 2x, 2x squared and 2x. Which way do I go? Well, which function is furthest, right? We need to be doing the outer radius first and then the inner radius. So when you envision this graph, or when you do a quick little sketch, you're like, okay, 2x squared, 2x, horizontal line. Ah, the parabola is further away. So it's got to be A, because the parabola is furthest away from our line of rotation. The line is closer. That's where the hole is coming from, the cutout. We're cutting things out. Whew, I'm thirsty, but I'm not going to pause this video. I'm going to finish it out. All right. A particle moves along the x-axis. For 0 to 10, the velocity of the particle is given by blah. At time t equals 0, the position is at x equals 4. Find the acceleration of the particle at time t equals 5. I was devastated that we did not earn 2 out of that I was devastated by the result on this FRQ. Specifically A, I was extremely devastated. Acceleration is the derivative of velocity. And so we just need to derive this velocity. The derivative of t is 1, and the derivative of sine times pi t is cosine of pi t times pi. And the derivative of a constant is 0. And we want to know the acceleration at t equals 5. So many people did not multiply by pi. They did not do the simple chain rule. Always be thinking chain rule. I don't know what to frickin' tell you other than that. Like, if you're always thinking chain rule, you're not going to forget it. I don't know, man. So then when we plug in pi, or sorry, excuse me, when we plug in 5, I forgot to write the number 5. Technically, we're done, right? I have said, I don't preach this because I don't want you guys to get lazy, but like this is a final answer. We don't actually need to do cosine of 5 pi, although to explain our reasoning to the last part, well, let me reveal here. If this is technically we found the acceleration at t5. Okay? Boom. But then it says, is the speed increasing, decreasing, or neither? Well, that comes down to the velocity. The velocity at the same moment is what? That. But does that mean anything to you? I don't know, right? You have to know your unit circle, right? Is what I'm saying. Like, you could just leave your answer like that, but now we need to decide, is the speed increasing, decreasing, or neither? Speed is increasing when velocity and acceleration have the same sign. That's something we said way back in Unit 4. Speed is decreasing if velocity and acceleration have different signs. And if one of them is 0, it's neither. Okay? If one of them is 0 or undefined, it's neither. Okay? So are they both positive? Are they both negative? Or do they have different signs? That's what's sort of ambiguous now. You need to know what these things equal, right? So let's go ahead and I don't look at these and know, right? I don't look at acceleration and go, "Oh, it's clearly negative." Right? I need to evaluate it. I don't need to kind of evaluate it. I need to evaluate it. Cosine of 5 pi. Well, 5 pi is maybe a little tough, right? Here's 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. That's when cosine is -1. So this is 1 plus -1 times pi, or as I like to say, 1 minus pi, which is less than 0 because pi is just call it 3. 1 minus 3 is certainly negative. Over here, 5 plus, well, 5 pi is the same thing, same angle, excuse me, but sine is 0. So this is 5 plus 0 minus 4, which is 1, which is clearly positive. So at t equals 5, the speed is decreasing since a of 5 and v of 5 have opposite signs. In context, explain the meaning. This was either you know it or you don't. We brought it up during that particle motion day, and it was a know it or you don't. That's why it was only worth 1 point. I wasn't gonna if somebody didn't get it down, they didn't go back and watch the AP Daily video. It's not a gotcha question. It's just, did you write it down? Did you get it? Do you understand it? What is now? To super backtrack, in Unit 4, we did say what this is. What is the integral of velocity? Because velocity can be positive or negative because that means left or right. But if you always make it positive, really what we're talking about is speed. And if you integrate speed doesn't account for left or right. It's just how fast you're going. And if you integrate how fast you're going, that's going to figure out how much you moved. Or, as we called it, total distance. The total distance traveled was 26 on the interval 0 to 10. Or from t equals 0 to t equals 10, if you prefer that. The total distance, this is a big buzzword, right? There's displacement and total distance. Maybe that's ringing a bell now. You're like, oh yeah, he did kind of make that connection to physics, right? Total distance versus displacement. It's different, right? Without the absolute value, that's the displacement. Because a lot of students wrote, you looked at that and you had a good mindset and you said the position of the particle changed by 26 units, right? Or the particle moved, the position moved 26 units. And it's just like, actually, if the total distance traveled is 26, the particle didn't necessarily change position. It could have moved 13 units right and 13 units left, and the position, as a result, was unchanged. But the total distance traveled by the particle was a whopping 26 units, but the position was unchanged. So this is not an integral about position, sadly. I know that kind of feels logical because you're like, oh, the integral of velocity is position. Yes, but we're not integrating velocity. We're integrating speed. What is the position of the particle at time t equals 10? This is exactly the same question, except of course by hand and without a calculator, as number 2. We need to take a known position, integrate the velocity to figure out where we are now. Okay? So we need to realize that the position of the particle is 4 at t equals 0. So if we know that's happening at t equals 0, that's the starting position, we just need to integrate the velocity for those first 5 seconds, and that's going to tell us our answer. So I actually had, well, I didn't, right? I'm just basing this off of scoring guidelines of past questions. I had this as the first point. If you just simply wrote that, that's going to earn you a point. So now let's do the math. 4 plus, well, what is the integral of the velocity? Let's go back up to the velocity function. What's the integral of this? We're going to increase the power by 1 and divide. The integral of sine is negative cosine. And then, well, there's this pi t, right? If we were to derive this, we would get sine of pi t times pi. The chain in the inside is times pi, so we need to divide by pi to cancel that out, of course. And the integral of 4 is 4t. This was the biggest. Always be thinking chain rule. Okay. So with that being said, that's our integral. So I'm going to drag that down, and we're going to go along the bounds 0 to 5. So 4 plus, when we plug in 5, we get 25 over 2 minus, clearly knowing what cosine of 5 pi is important. Cosine of 5 pi is -1, but the negative times this negative is actually going to be a plus 1 over pi, and then minus 20. Minus, plug in 0. 0 squared over 2 is 0. Cosine of 0, because 0 times pi is 0, is positive 1. So this is going to be a minus 1 over pi, and then minus 0, because 4 times 0 is 0. Right? Just plug those in. So we could write this as 40 over 2 if we wanted. So that's 4 plus 15 over 2, or negative 15 over 2. Actually, let's just combine everything now at this point. 15 over 2, this 1 over pi minus the negative, that's plus 2 over pi. This is minus 15 over 2, sorry. Right, 25 minus 40 is negative 15. This is 8 halves. 8 halves minus 15 halves is... Also, when could we stop? Right there. Without having even turned this into a 40. This is the final answer. I don't like to advertise that you can stop. Right? Because... And even... What is an acceptable answer is not even this. What could we have done? We could have said 4 plus 25 halves minus cosine of pi times 5 over pi minus 4 times 5 minus 0 squared over 2 minus cosine of pi times 0 over pi minus 4 times 0, and stopped there. That's a final answer. This simplifies a little bit nicer to 7 over 2 minus or plus 2 over pi. I think that's about as clean as it gets. You could get a common denominator and add those. Feels a little unnecessary. But because this question is like, again, we're almost at 90 minutes. I need to freaking shut up and move on. I got a life here too, folks, but I'm doing this for you. This question is meant to test you on what? Do you kind of understand this basic setup? That if you take a starting position and add, what is this finding? The change in position. This is how much the position changed. Not this up here, right? That was the total distance. This is the change in position. So if we take where we are and we add the change, that's going to be where we ended up. So this earned a point. The act of integrating earned a point. And then just having some sort of a final answer is the third and final point. No matter how pretty or how ugly that final answer was presented. But many of us just made, like, you integrated and then just tossed on +4 at the end as if it were the constant, and then just plugged in 5 and just completely ignored plugging in 0. Plugging in 0 did not get us 0. Plugging in 0 got us -1 over pi. Many of us just totally ignored plugging in 0. And yeah, and it kind of looked like you thought kind of made me think that you thought plus C was the 4. I don't know. It was just very ambiguous. This is a clean start. This has got to be your start. It's just got to be. Like, that's the foundation. That's the foundation. All right. The position of the particle is given by x of t. Write an expression, write the expression for x of t, knowing at time t equals 0, the position is at x equals 4. So this question is basically, hey, find c. Now, there was a student, two students, who wrote this. Oops, no DT. And just stopped. Because it said write an expression for x of t. And technically, not even technically, this is beautiful. This is beautiful. It kind of, I was like, oh wow, totally a different interpretation of the question. And I was like, you know what? The scoring guidelines that I'm looking at didn't even present that, but I was like, you know what? This is too good not to just give the points. I think this answers the question. It wrote an expression for x of t. Take, you know, we are starting at 4, right? And it made the, right? It turned the integral into a function, which we've seen that in the past, right? It turned the integral into a function. I like it. But what was I and what were the scoring guidelines imagining? They were imagining that you integrated, had a plus c, and then plugged in 0 for t, and set it equal to 4, right? Because when you plug 0 into your function, you get 4. So this would allow us to solve for c. Oops, that's a 2, not a t. So this just gets zeroed out. This just gets zeroed out. Earlier, we discussed that this was -1 over pi. So c is 4 plus 1 over pi. And now that we know the value of c, we can write our final function. T squared over 2 minus cosine of pi t over pi minus 4t plus 4 plus 1 over pi. And there's our x of t function. Even with pausing and explanations, 1 hour and 25 minutes. Perfect. You know, while it's just on my mind, let's look at the most missed questions. Which ones were the most missed? Let's go back and just, you probably don't even want to watch anymore, but at this point, I'm just kind of talking to myself. Let's look at number 9. Nine was the most missed question. 31 people chose B. "31 people chose B. Oh, man. But this isn't the bottom. Top minus bot. That's just the bound. That's just the bound. That's just the, right? Why is the why 31 people chose B? Man, man, that almost makes me want to cry. I literally could almost cry from that. I mean, I've even seen people write on their notes and in the whiteboard top minus bottom. That's not, like, people were saying, I feel like I've heard students say that out loud. I don't, to me, that just doesn't, and I mean, I guess it had the bound of 1. Maybe that is like what felt, you're like, okay, that's perfect bounds. Boom, moving on. I don't know. Okay, well. Number 5 was a calculator active one. It's impossible to know what, yeah, a little tough to analyze the options there, so I'm not going to. Number 13. I think it goes to show the calculator was easier because of the most missed questions. 5 is a calculator one, and then non-calculator, non-calculator, non-calculator. It's not till halfway down that I see another calculator one, so I think that's nice. 13. Ooh, I told you I thought students might think this one was most chosen answer was C by about 8 more than A. And that's just the wrong slope. So I think yeah. Also, C at least had the A as the bound. I'm a little surprised that 10 people chose, or 15 people chose between B and D. The bounds just, why are we using the, I mean, C, I get why C is appealing, but it is a downward trajectory line. Okay. I think I spoke a lot about this problem though, so I won't dwell on that. Number 6. Oops, went too far. Number 6. Number 6, I mean, I dwelled on this one too. It's interesting. I seem to have dwelled on the problems that ended up being the most missed. This one being exactly like the progress check, I don't know. If you read the I don't know. I think the progress check is the holy grail. I think the descriptions of the right and wrong answers are of tremendous value. And if you don't spend at least 30 minutes trying those problems and another 45 minutes reading the paragraphs that someone has taken the time to write for you, I don't know, man. I don't know why you didn't. I don't know why you didn't. All right, number 11. Number 11. Yeah, I mean, I mean, I do think this one's harder, right? Like A, I bet some people are just like, A's just there to distract me, right? With this, like, I'm not even gonna entertain that as an option. I'm just gonna look at the other ones. Hmm. Right? It's two different regions. It's two different regions. Number 12. Oof. Very 50-50 between D and C. Hmm. Maybe that question's a little unfair. Because I was having a hard time explaining the difference between those two. Yeah. Huh. I mean, there's nothing I can do about it now, but in hindsight, maybe I make that a calculator active question. I don't. I know pi over 8 is smaller, but it's just like, is there. I'm trying to think, is there something that I could demonstrate? Like, I'm thinking, like, what if it was an ACT question and it said, like, organize the numbers from least to greatest, right? They have those types of questions where it's just like, do you understand fractions? Do you understand the relationship between all of these numbers? And I'm just trying to think, like, why is 2 root 3 obviously bigger than pi? I guess I did have this analogy of, well, we're closer. Oh yeah, I did say that. We're closer to square root of 4 than we are square root of 1. And with that being said, it's got to be bigger than 1.5, right? But those are very close. Those are very close. Hmm. Okay. Yeah, maybe that should be calculator active. Number 4, calculator active. I won't dilly-dally with that too much. There's just nothing valuable there to analyze. It's just decimals. Nothing valuable to analyze here with number 10. I can understand. I mean, 10 being A was this. A lot of people chose 10, a B. How about that? Okay. Well, I have made a long enough video here. So, get out of here.